Welcome to this comprehensive guide on utilizing the Performance Analyzer tool within Unity and Visual Studio, designed specifically for beginners. This tutorial will walk you through the essential steps to identify and resolve common performance issues in your game development projects. Understanding and resolving performance bottlenecks is crucial for creating smooth, responsive applications and games. A well-optimized game not only provides a better user experience, but also ensures broader compatibility across various hardware configurations. Today, we'll explore how to effectively track down those pesky FPS drops and garbage collection spikes that can hinder your project's performance. These issues, if left unaddressed, can lead to frustrating lag and an overall poor user experience. First, let's open your Unity project. Navigate to the Window menu, then Analysis, and select Performance Analyzer. This sequence will bring up the dedicated Performance Analysis window within your Unity editor. This action will launch the Performance Analyzer window, ready for you to begin profiling your application. This window serves as your primary interface for monitoring and diagnosing performance-related issues. Now, to connect Visual Studio, ensure your Unity project is open in Visual Studio and that the Unity debugger is attached. This connection is vital for a comprehensive analysis, allowing you to inspect code-level performance. In Visual Studio, go to Debug, then Windows, and select Performance Profiler to access its tools. The Performance Profiler in Visual Studio offers additional insights, particularly for CPU and memory usage at a deeper level. The Performance Analyzer interface features several key areas, including graphs for FPS and GC, and a detailed event timeline. Each section provides unique data points essential for a thorough performance review. The FPS graph displays your frames per second over time, providing an immediate visual indicator of performance fluctuations. A consistent, high FPS line is generally desirable, while significant dips signal potential problems. The GC graph, or garbage collection graph, shows memory allocation and deallocation, which can cause noticeable hitches if not managed efficiently. Frequent or large spikes in this graph often point to memory management issues that need attention. To begin profiling, simply press the Record button in the Performance Analyzer window while your Unity application is running. This initiates the data collection process, capturing real-time performance metrics. Once recording, interact with your application as a user would, performing actions that might trigger performance issues. This could involve navigating complex scenes, engaging in combat, or interacting with UI elements. After capturing enough data, click Stop to halt the recording and analyze the collected metrics. The analyzer will then process the recorded data, presenting it in an organized and interpretable format. Look for significant dips in the FPS graph. These indicate moments where your game struggled to render frames quickly enough, often due to heavy processing or rendering tasks occurring simultaneously. Similarly, sharp, sudden peaks in the GC graph signify large memory allocations that could be causing performance hitches. These spikes often correspond to moments where the garbage collector is actively reclaiming memory, pausing your application briefly. You can zoom in on specific time frames by dragging a selection box over the graphs to inspect detailed events. This granular view allows you to pinpoint the exact moments and durations of performance anomalies. Below the graphs, the event timeline provides a chronological list of operations, helping you pinpoint the exact cause of performance issues. This timeline is invaluable for correlating visual performance drops with specific in-game events or code executions. Clicking on an event in the timeline will often reveal more detailed information, such as the function call stack or allocated memory. This deep dive helps you trace the performance issue back to its source in your code. Common causes for FPS drops include complex shaders, excessive draw calls, or unoptimized physics calculations. Identifying which of these factors is most impactful requires careful analysis of the profiling data. GC spikes are frequently caused by creating new objects or strings in performance-critical loops, leading to frequent memory cleanups. Understanding where and why these allocations occur is key to mitigating GC-related performance issues. A helpful tip: use object pooling for frequently instantiated objects to reduce garbage collection overhead. Instead of destroying and recreating objects, pooling allows you to reuse them, significantly cutting down on memory allocations. Another tip: optimize your code to avoid unnecessary string concatenations or allocations within update loops. These seemingly small operations can accumulate quickly in performance-critical sections, leading to noticeable slowdowns. Consider using Unity's Burst compiler and job system for computationally intensive tasks to leverage multi-core processors efficiently. These advanced features can dramatically improve performance by distributing workloads across multiple CPU cores. Regularly profile your application, especially after making significant changes, to catch performance regressions early. Integrating profiling into your development workflow ensures that performance remains a priority throughout the project lifecycle. Remember, even small optimizations can collectively lead to substantial improvements in overall application responsiveness. A series of minor adjustments can often yield a greater impact than a single, large optimization. The Performance Analyzer is an indispensable tool for any developer aiming to deliver high-quality, performant experiences. Mastering its use will elevate the quality and professionalism of your Unity projects. By systematically identifying and addressing FPS and GC issues, you can significantly enhance the user experience of your projects. A smooth and responsive application is a hallmark of quality and attention to detail. Keep practicing these techniques, and you'll master the art of performance optimization in no time. Continuous learning and application of these tools will make you a more effective and efficient developer. Thank you for watching this tutorial on the Performance Analyzer tool. We hope you found this guide informative and practical for your Unity development journey. We hope this guide helps you build faster, smoother, and more enjoyable applications. Don't forget to subscribe for more tutorials and tips on Unity development and performance optimization.